Okay, in this video I want to introduce multidimensional arrays, primarily two-dimensional arrays, also referred to as a table or a matrix. An example is, you can see I declare the constants for the rows and the columns, then we declare the 2D demo array, we use the brackets. So in this case we have two sets of those brackets. In the first one we'll specify the amount of rows and the second the amount of columns, and to set all of those elements in this 2D array to 0, I'll use an empty list initialization, you can see here to the right, before the semicolon to terminate that statement. Let's say we want to keep track of game character experience gained per encounter, so you have multiple encounters, and with each encounter you want to store how much experience the character gained in that encounter. So once again I have these two constant integers, characters I set to 2, encounters I set to 3. I go and declare my array, called XP gained per encounter in this case. Once again we have those sets of brackets. In the first one I have characters and in the second encounters. We've seen how to declare these 2D arrays, but how can we now initialize them? Well, you can see I have essentially the same thing here, those two constant variables that will specify the characters and the encounters. Then we have that list once again, but instead of passing in single values like we had before, we are now passing in these lists. So it is basically a list that contains other lists, right? So an array of arrays. You can think of the first element as pointing to another array. Well, you use the list initialization to initialize that. Once again, so you have the curly brackets, you add the elements in there, you make sure you have a comma, then you specify the next list, and once again you make sure to end that statement off with the semicolon. To the right you'll see a table where I lay out more or less what this will look like. So 0, 0 will give you 4, 1, 1 will give you 5, 1, 2 will give you 9. This is basically what I mean by this is an array of arrays. In the first element, so that first subscript, these are also called subscripts, so either an index or a subscript, right? So in that first index, in the first pair of brackets, that specifies or points to an array. So your first array is basically just the location of another array in memory. So let's say you want to go to the second array, you pass in 1, and then that array once again has an index of 0 to 2 in this case, because we have 3 elements in that list. So if you want to access an element in that list, then you go 1, for example, to access the second array. Then within that second array, you pass in the index that you want to access. So the index that will point to the specific element that you want to access within that list. Here's the example once again. So I had to kind of cram the left side here just a bit, but you have the same declaration and initialization on the left. On the right you can see I do cout XP gained per encounter, that is our array identifier. So how can I specify what I want to access? Well, once again I do 0 or 1. So 0 will point to the first list, 1 is going to point to the second list, as you can see here. And then in the second subscript operator or the second pair of brackets, you can see I have question marks. Don't write it like that, this is just an example, of course, but that now allows me to specify exactly what element I want to go and access. Now as a quick example, and we'll actually see this in Visual Studio later on in the video, but let's say we do 1 for the first index. That will of course go to the second list, or point to the second list, so where that is in memory. Then let's say we pass in 2 into the second pair of brackets. Then we can see here we are going to access in that second list. That'll give us 9, the integer 9. Okay, just like with one-dimensional arrays, we can iterate over 2D arrays using for loops. For your notes here, I have a comment that says nested for loop to output the matrix row by row, or the table row by row. So in the first line we have the rows, and the second one the columns. So this is based on the first example, right? A demo 2D array. Once again, for each iteration of the outer for loop, the inner for loop is going to repeat. This way for each row, so let's say you have row 0, you can basically go and print out that entire row, because you have, let's say row 0, it's going to go to column 0, and then 1, and then 2, so in that way it's going to print out your entire row, right? Here you can see the XP gained per counter example once again. So you have the rows, that is the characters, and then the encounters, once again are the columns. So if you want to print all of those out, then once again you start with row 0, for example, and then you go and print out. So you iterate over the column, row 0 once again, column index 1, and so on. In this way, you'll print that out. Once again, we'll show you in an example here in Visual Studio next. Okay, here I have the same demo, so XP gained per encounter. I have the constant integers. You don't have to do it in this way. You can just pass those in, of course. I'm just trying to make it easier to see what this array is all about in this way. Alright, then I go and initialize that, of course. So I initialize using this list notation. Note the comma. So if you have 3 of these, then you'll have a comma right here as well. So we separate those lists out using the comma operator. Right here I print this out. So similar to what you are familiar with already, using the subscript operator or those brackets. But in this case we have 2 of those right next to each other, and then I just do 2 end lines here before we do the nested for loop. I'll just go and run this quickly and you can see we get 9. I'll talk about the nested for loop here in a second. So how do we get 9 here? Well, once again we go to 1. So this is 0, this is 1. Then we go to index 2, 0, 1, 2, so that is 9. So once again you can think of the first one as an array that holds an index or points to some other array. So 1 will point to this list here, this array. Then we use 2 here to go and select what element we want from that array or from that list. So that's easy enough. I'll comment that out. Then we have the nested for loop once again. So we start with the characters here, so less than characters, which is less than 2, so 0 and 1. Let's say we start with 0, and then this one here encounters as well. So I is 0, j is 0, so this will print out 4. Then of course this inner loop will repeat again. This will now be 1, so j will be 1. I is still 0, so 0, 1, which is 7. Then 0, 2, which is 8. Then I will be 1. So we go to the second array. It will now point to the second array basically. So each time, once again, we are going to repeat the inner for loop for each repetition of the outer for loop. So when I is 1 and j is 0, we go 0, 1, and then 0, which is 6. So then we do I 1 again and j 1. So that will be 5. And then once again I 1, j 2, which will give us 9. So I purposefully kept this as simple as I can. Of course, you can go and do more. So if you go and do another list, you do a comma, and you go and add it down here, right? And of course, then you want to make sure that you actually have space for that right here. So if you want to increase your rows, you need to go and increase it right here. And then you can actually leave this the way you want, depending on how many elements you want in each row. But basically, if we go and build and run this, you'll see we get the same numbers that we get. I'll just go and bring that up again. We get that printed out similar to how we have it initialized. It's nice and readable. Just remember your spaces and so on, again, depending on how you want to put that out to the console. And here, once again, the end line after every row has been printed out. In the previous example, we stepped through the array row by row. Now, as a quick exercise, I'd like you to try and step through it column by column instead. Print them out, side by side in a column format, as you can see in this example. When I come back, I'll show you how you can do this. Previously, we stepped through our array row by row, and of course now we want to step through it column by column. So what we have to do is we have to go and change these around. If we try and build and run this now, you won't get the results that you expect. So what I'll do is I'll go and change these around. And I'm going to keep this as is. And that should work fine now. Just make sure once again that if you have this declared, you want to make sure that I is also now changed to j in the condition. and then also in that increment section as well. The same for I. I'm just going to build and run this and see if it works. And as you can see, we now step through the array column by column. So instead of having it in a row layout, we now have it in a column layout like this. Now, of course, you can go and change the subscripts around. So J and I, you might have tried that initially. So we have this as it was in the previous example, and then I just go and change J and I around. And that will work too. You can see that will work fine. And of course, we still swap these two around, right? Your rows and columns. Okay, so one final thing I'd like to demonstrate is that, so let's say you go in and you declare and initialize this array here, but you go and leave out these subscripts, right? To declare the size of the array, you might not get the results that you expect. So that is why I'm doing this section. So let's start with this. Let's go and remove that first, a size declaration. And I'll build and run this, and this should work fine. You can see that will work fine. Alright, I'll undo that. I'll remove the second one. And we get an error. Missing a subscript. What you can do is you can remove the first one, so the compiler can deduce the size that it has to set aside for that first list, but it cannot go and deduce the size for the second one. So even though it might seem obvious, and even though we go and initialize it right here, it cannot deduce the size for the second list. So we need to go and make sure to add or declare the size for the second subscript. Otherwise we'll have issues. So you cannot leave both of those empty, and you cannot use only the first one and leave the second one out either. But when it comes to multi-dimensional arrays like this, I prefer to have an explicit declaration like this. Alright, so I hope you find this useful. Finally, I'd like to mention you have, of course, more than just 2 dimensions. You can do 3 dimensions, so 3D arrays. And in this case, you have an array of arrays of arrays. You can do arrays with more than 3 dimensions, but for the most part, you'll be using 2D arrays or 3D arrays. So for the most part in this course, we will only use 2D arrays, 1-dimensional or 2-dimensional arrays. We will not go beyond that. It can get really confusing. It's not that confusing if you think about it in this way. So once again, the first index or subscript is of course an array, as you had it with 1-dimensional arrays. But each element in that array points to another array, and then each element in that array that is pointed to by the first array is once again another array. So once again, it's a bit weird at first, but maybe if we break it down in that way, it's a bit easier to follow along with how that works. If at this point you had trouble with for loops, you did not understand how the iteration worked and so on, once again, just spend some time with it. And this is why I always mention that you cannot just watch videos, you have to go and practice and try and understand by yourself the concept. So for loops and nested for loops, I mentioned we are going to use that in this section. Similarly, in module 102, we are going to use a lot of what we've learned in this module, and at that point I'm going to assume that you're comfortable with what we have discussed in this module. Because once again, once we add object-oriented programming and everything on top of what we've discussed in this module, it can be a bit overwhelming if you are not comfortable with these fundamentals, right? So that is going to wrap things up for this video. I hope you find it useful, and I'm going to see you in the next section.